Yeah, good morning. For those of us online, I said you are welcome to today's class, which is the last front end session. And it has been an amazing and interesting journey. So, giving the mic to anyone that wants to speak on how the journey has been for the person, if it has been amazing. Yeah, we know it's not easy, but it also takes a lot to reach this certain stage. So if you just have something to say about your journey so far, you can speak. You can just raise your hands up if you're online so I could allow you to speak. Is anybody trying to speak or say something? Adewale, do you have something to say? Bolarinwa, do you have something to say? Oluwapelumi, Yusuf, Adelu, does anybody have anything to say? Sam, oh, okay. Yeah, can I let's hear Bolarinwa. Yeah, Bolarinwa, you can speak.
Hello, good morning. Hello, good morning. Can you hear me?
Yeah, we can hear you.
Yeah, thanks for the from the starting of the shoot camp. We really appreciate your time and your efforts trying to make impact in the boot camp. So, my question is still far back to yesterday because it just came to my thoughts when I was talking to someone that we are doing this same boot camp together. So the person is, I think the guy is the backing guy. So we're now talking like, okay, he now said there's not be attending classes like that. So in case we what was it called? Need somebody like that. How should we go about it? Like I don't know if you get my question, sir.
Okay, so you're trying to ask if someone does not be attending the classes, how can they move forward or what?
It's not really how can you move forward. Just I'm just asking case of the what we call hackathon that okay, the person has not been attending class and may even understand most aspect of let me say the back end of this. Like okay, I was I'm a front end developer. So like just
Okay.
one back end guy that will work with us and the funniest part is that the people that we see off they are in other team that we can't even get in the team. So we now find another person. So the person has not been attending class and that's another issue entirely. You don't even understand some things that okay we need to do about it. So how do you think like how can we go about that? So that's what it is.
Oh, okay. For that, I believe one, if you're not attending class, you won't be participate in the hackathon, right? That's one thing to also understand. So I believe the list for those who qualify for the hackathon will be released this weekend. That will be on Friday, right? So at that particular point, that should be like an elimination for people that have not been attending the classes. And then in scenario where probably the guy is part of your team already and isn't up to the tax. Now for that, it's not really a rule or principle, but what I would recommend is you can always you can speak to the particular person and probably let him know and make him see that okay, it might not be able to cover, it's not up to the tax for your particular project. And from there, you can even take it up with the management, right? So you can speak to the management about it. That's Sumaya, and she can take it up from there also. Yeah.
Thank you. And again with the what was it called? Can you see him?
I didn't get you.
Like I'm still having one issue with get connector stuff. Like it's not connecting. Like it's just asking for a get connector that is not connected with the recent widening. So because
Okay,
I've
with
created it.
your okay, we can probably later in the day you can reach out to me and then we'll take a look at it again. You can do that, right?
Okay, so thank you.
Did you get all right? Yeah, Yusuf, seems like you wanted to say something also. Please, we just have 4 more minutes and then we'll get into today's class because we still have things to do.
Hello.
Yeah, we can hear you. Yusuf.
Hi. Good morning. Good morning, boss. Firstly, I would like to thank you very much for the classes and the sacrifices. So, without taking much of our time, my question is still about the um hackathon hackathon space we had yesterday. So, Somoya I emphasized yesterday that in the team they're expected to have at least one back end guy and one front end. So now I want to clarify: is it that someone from the back end track for this particular bootcamp, and another person from the front end track for this particular bootcamp, or someone that is generally back end and someone that is generally the front end, regardless of the bootcamp.
So I believe people that are generally backend went for the backend class, and people that are generally front end went to the front end class. So the what I would say is it depends on your particular team member. So if your team member believes it's up to the task to probably handle the front end aspect or the back end part of things, then you can go ahead to join your team. So it depends on the capability of that particular person trying to join your team as with certain tech stack. So if part of the people taking the front end class, because I know some back end guys are also taking the front end class. So if they believe they can undo the front end part of things, yeah, they can go ahead to do that. So you guys need to sit down and make sure you ask, okay, who is willing to join as a back end engineer? Who is willing to join as a front end engineer?
All right, thank you very much.
Yeah. So Sam, you can speak. Please, let's be audible so that everybody. You pass. Oh, okay. Problem. All right. So we'll be moving on to today's class. Today we're talking about messaging, that is cross-chain messaging. But we didn't finish yesterday's class. That's our code. So the practical session had a bit of issue, and that issue was based on the gas fee. So we didn't have sufficient gas fee at that particular point, and as a result of that, our code kept failing. So I'll go ahead to share my screen and also to see how we can deploy. Please let me know when you can see my screen. Please can you see my screen? Those of us online.
Yes, you can see.
Oh, okay. So what's left for us is we are trying to test out our code, what we wrote yesterday. So I'll just go ahead to run the code. So we don't. So let me get my other. All right. So at this particular point, you can see our custom gateway for L1 has been deployed, and currently our custom gateway for L2 is deployed. Now, once this is successful, the tokens will be deployed. Now, as we're waiting for this to deploy, from yesterday to today, I'm sure some of us were wondering, as front-end developers, how can we do this in our front-end code, right? How can we work on this? So yeah, I was able to restructure the code, and I would push this probably after the class, yeah, because to start going through it is going to take a bit of time since we still have a full class to take. But for us to, let me just give a brief overview, right? So I created a new file, and yeah, so I'm still making use of the JSON providers. Let me zoom in. So we'll just do this while this is deployed. Yeah, so at this particular point, we can see our custom token to L1 has been deployed. This is the address of our custom token to L1. And then also custom token to L2 has been deployed. This is our address. It is setting, so currently it's trying to set the bridge information on L2. That has done that on L1 already. That sets the bridge information. This is our transaction hash. And on L2, it's currently doing that. So this is the whole flow. If you want to view any of this, you can always pick it up and go to the Explorer and view that. You will see that you get a transaction. So this is for, to come again, this is our custom gateway deployed at this address. This is for our L2. And then this is for our L1. Our custom token at L1, and then our custom token at L2. Yeah, so this is how it all works. So that's because. Yeah, so let me run this again. That'll actually fit. Okay, so coming back to our Next.js application. To understand this, every package that we used while trying to deploy or even run our custom gateway, now we can make use of the same packages for our front-end application. Now, the difference is this. If you're going to deploy from your front-end, now you can use your ADAS to deploy, and then you get the address and read the contract from there. But this time around, we are trying to deploy from our front end itself. So how do you do that? So you get the API of the contract, and then there's also what we call the bytecode of the contract. All of that can be getting from Remix. If you compile, you will see ABI and bytecode. So once you have that, you can now use ETAS to deploy your contract using this contract factory. So you pass in the L1 custom gateway API. You'd also pass in the bytecode and then your signer, which is your wallet. So these are the only things you need to change. You just need to change this. And then you can also add your custom wallets, right? So once you have all of this, you are good to go. You do your normal import, you're good to go. So I would push the contract itself. So these are the contracts we are using, right? They are provided by Arbitrum. So you don't need to write them. So I'll push that alongside. So once after the class, you can just check yesterday's code. That's training 23A code. You would see all of this. And then you would also see if our label is front end. So you would actually know how to run your code from the front end and how to deploy from your decentralized application. Are we good with that? Yeah, are we good? All right. So still running. So I think we'll just go ahead to start today's class because this can take up to 15 to 20 minutes. So we don't just waste our time or just keep waiting. For those of us online, do we have any question so far? All right. So yeah. So far we have seen that our token has been confirmed on L1 using the admin breacher. This is the transaction hash. Now we are waiting for the L2 retriable. So this will take 10 to 15 minutes, remember. So for the transaction to be executed on L2. So once this is done, we can now deposit, approve and deposit. So this is how it works. Okay, so today we are looking at messaging in the Arbitrum. Now, we have seen in our in our previous classes, the Arbitrum bridge works by messages, right? Messaging from L1 to L2 and L2 to L1. That's what we have seen so far. So today we'll take an in-depth look into how does this messaging work. So our objective for today's class is we would understand messages in Arbitrum and also a comprehensive understanding of Arbitrum's L1 to L2 message passing system. All right. So retriable tickets in Arbitrum, they are Arbitrum's canonical method for creating L1 to L2 messages. We saw a brief explanation of this 2 days ago. So what we'll be doing today is we'll look at the life cycle of the retriable tickets. How do we send how does this message lifespan work? How long does it last? What happens if it fails? What happens if it succeeds? So we're looking at that. So the first step in retriable tickets, the life cycle is what submission. So this is you sending, this is the message being sent. And then this message is going to be stored in the inbox. Now, inbox is just so it's just typically your um phone messaging flow where you send a message is stored in your inbox, and then from there it can be dispersed. So in like manner, we have submission and then we have auto redemption. So this auto redemption is the message being redeemed. So the message could come with a value, that is with the amount you're trying to transfer, and it can be auto redeemed. But this auto redemption is dependent on certain conditions. So if it fails, that's at that particular point, that's where manual redemption now comes in. So that manual redemption is used when it fails. So in understanding the submission, a retriable ticket is initiated with a call to the create retriable ticket function of the inbox contract. So there's an inbox contract, and how you create a retriable ticket is you make a call to a function in that contract. Which function is that? Is the create retriable ticket. Now, the ticket is guaranteed to be created if this call succeeds. So it's basically you are creating a ticket whenever you make a call to this contract, and that particular ticket is created if the call succeeds. So note that this function forces the sender to provide a reasonable amount of funds, at least enough to submitting and attempting to executing the ticket. Now, we saw yesterday that our contract kept failing. Why? Just because we didn't have enough funds to go ahead with the transaction, and that's why it kept failing. So, and the reason is because this function actually forces you that is trying to pay that you must provide a reasonable amount of funds first before it can proceed with the transaction. So, and that fund should be able to cover the submission and also the execution of the ticket. But you need to understand that you having that fund is not a guarantee that there will be a successful auto redemption. So this is the first step in your retriable tickets. You create a retriable ticket first, and then that ticket is initiated with a call. Now, the second point in this submission is what the sender's deposit must be enough to make the L1 submission succeed and for the L2 execution to be attempted. Now, if this is provided correctly, a new ticket with a unique ticket ID is created and added to the retriable buffer. And then once this is done, the funds will be deducted from the sender and placed into the escrow for later use in redeeming the ticket. Is this straightforward? Is our code straightforward? So code is deploy. Do you have any questions so far? So we can just give a brief explanation of the two submission points that you are giving so far. Just give a brief understanding, like just explain from your own understanding of what we mean. Anyone? Is anyone trying to give? Should I go through it again? Okay. So we are talking about the retrievable tickets lifecycle. Retrievable tickets. Now they are Arbitrum's method. When we say economical, what we mean is like reliable or easy to use method, right? So these are Arbitrum's method for creating L1 to L2 messages. So that is L1 transactions that initiate a message to be executed on L2. So it's just more like a message system. You want to deliver something. If you want to deliver from here to another state or another country, you use a parcel delivery system, which is more like a message system. You sending a message also. Now, how does this message system works? It works through retrievable tickets being created. And then these retrievable tickets being created, they usually carry messages. These messages will be executed on L1, to be initialized on L1, and then once everything is provided and everything is valid, they are now executed on L2. So this is how the messaging system works. And then it's a life cycle. If you are sending messages or deliveries, the life cycle is going to be involved. And that's because one, you the sender, then the delivery man or the middleman, and then the receiver. That's the life cycle of a delivery, of a normal delivery system. Now, in this retrievable tickets life cycle, there's also the submission, and then there's the auto redemption. Now, auto redemption is what executing the transaction on L2. And then there's manual redemption. Manual redemption is this comes to play whenever auto redemption fails. So that's it. Now, in talking about submission itself, how do you then create a retrievable ticket? This ticket is created with a call. So there's the Arbitrum inbox contract. So you make a call to the create retrievable ticket function on that contract. And then once you do that, the ticket will be created for you. Just you making a call to a function on the inbox contract, and then automatically the ticket is going to be created if the call succeeds, if the function runs without any issue. The ticket is going to be created. Now, before this ticket can be created, the sender has to have enough funds to cover both the submission and execution. So you sending the package or delivery in the traditional sense, you need to have enough funds that will cover the cost of transport and everything, and also the delivery to that particular person. So if you don't have enough funds, your code is going to fail. Your messaging system is going to crash. Right. Now, but then the fact that you have enough funds doesn't guarantee a successful auto redemption. So we'll still understand why that happens. Now, in this second point, what we're trying to say is this: the sender's deposit must be enough to make the L1 submission succeed. And for the L2 execution to be attempted, if provided correctly, a new ticket with a unique ticket ID is created and added to the retrievable buffer. So when we say retrievable buffer, is that for now in this code, we can see that we are waiting for L2 retrievable, which takes a bit of time, takes 10 to 15 minutes. So this means it will keep buffering, right? When we say buffer in the traditional sense, it means like you're fetching bit by bit. Yeah, yep. For our backend guys, we're supposed to know that. So this is a practical example is in our code, where we are waiting for the L2 retrievable. Now, moving on, once this ticket is created, the funds is going to be moved from the sender's address to the escrow. Remember, we have gateway for escrows in yesterday's class. Yeah, the middleman. So it's going to be placed in the escrow for later use in redeeming the ticket. So all of this is just everything that we did yesterday is basically, this is like the explanation of the flow. The other you see, we had the custom gateway, why that's as the escrow. And then in the messaging, L1 to L2 messaging, we can now see that it's actually you can all see everything in play and how everything works. So that's that for submission. So submission involves what? One, it involves making a call to the function, and then secondly, you having a reasonable amount of funds to cover submission and the execution on L2, right? And so moving on to automatic redemption, we need to note that the submission of a ticket on L1 is separable. That is, it's different from the execution on L2. Yeah, it's asynchronous. So that is you giving the middleman is different from the middleman delivering to the recipient. Right? They're not the same thing, they're different. They happen at different times and all. So once the ticket is successfully created, the two following conditions are checked. And what are the two conditions? So remember I said auto redemption can fail. And reason be that these two conditions must be valid before it can be redeemed. One is if the user's L2 balance is greater than the max fee gas, so your gas that you pay, if the user's L2 balance is greater than the gas or equal to, so are there, if it's greater than, then to proceed. But then if it checks and then you see that the user doesn't have enough balance for the gas fee that you pay, so it automatically fail. And then we also have if the max fee per gas provided by the user in the ticket submission process is greater than the L2 base fee. So the L2 also has its base fee. So it will actually check if base, that is the minimum fee you can pay. Yeah, so when we talk about base, it means like ground level. So it will also check if the gas you are paying is greater than the base fee, the L2 base fee. Now, if these conditions are met, the ticket submission is followed by an attempt to execute it on L2. Do you have any question on this? Is this straightforward? That is the minimum fee that you can pay. So it's going to be provided from Arbitrum itself. Yeah. So those of us online, do you have any question? So the base fee is basically like just like gas fee, but this time around is for the L2, for the L2. Yeah. So for the transaction, so yes, for the execution. So moving on, if a redeem is not done as submission, but the submission's initial redeem fails, for example, because the L2 gas fee has increased unexpectedly. So you would wait for a while for it to be executed. So now this started 10:39. This is 10:46. This is still moving. This is almost 10 minutes. Now there's a scenario where within that 10 minutes, the gas fee can increase unexpectedly. And remember, what controls gas fee? There are different factors that controls gas fee. One, no, I'm not talking about in interacting with smart contract. Like generally, if you want to send, there are certain times where you want to send transaction, maybe in the night, you see that gas fee is for Ethereum, you can see $10, $4, right? Or 4 liters for gas fee. And then you check again up to, and then you see gas fee of about $100 worth of ether. And then you're wondering what happened, how did this increase? There are factors, huh? not so you know there's network congestion. There's not so network congestion also determines gas fee, and then amongst different factors. We did this class that was beginning of this bootcamp. We treated this. Yeah, so in scenarios where maybe the L2 gas price has increased unexpectedly, the submission fee is collected on L2 to cover the resources required to temporarily keep the ticket in memory for a fixed period, and only in this case, a manual redemption on the ticket is required. Now, what this is trying to say is, if the submission's redemption fails, or the auto redemption fails, what's going to happen is this. It's going to be moved to the L2 is going to collect the submission fee. Remember, everything is still with the escrow. So what's going to happen is the L2 is going to collect the submission fee, and then it would collect that in order to cover the resources required to temporarily keep the ticket in his memory for a fixed period, which is 1 week. So if it fails, what that means is the L2 is going to keep it in memory for a fixed period, which is usually a week. And then within that week, if you want to redeem it, that's where manual redemption comes in play. Do we understand? Okay. I'll check why big number is failing. Okay, so moving on. How does this manual redemption work? It works if the fixed period elapses without a successful redemption. The ticket expires, and then to be automatically discarded. So unless some party has paid a fee to keep the ticket alive for another full period, the ticket can live if indefinitely, as long as it is renewed each time before it expires. So this manual redemption works in the sense that when the L2 um sorry, just a minute. Okay, so this works in the sense that when within the fixed period, anybody can come and try to redeem the ticket, right? That has been moved to L2 for temporarily. Now, if that ticket expires, nobody comes and nobody was able to redeem it successfully, what's going to happen is within that fixed period, once it's done, the ticket is going to expire. And once the ticket expires, your gas fee is gone. But then I'm sure we'll be asking, what about your core data value? That is the funds that you sent. Maybe you're trying to send 10 tokens and then it fails. What happens to it? Does it get lost? It doesn't actually get lost whenever the ticket expires. So what happens is there's this refund core data address also. Yeah. So you can provide that and pass that whenever you are messaging in your flow. Once you provide that, what happens is whenever the ticket expires, your core data value is going to be moved to that address. And then from there, you can now take it up later on. But if you want to still keep the ticket alive, what you can do is you can always come and pay a fee. So once you pay that fee, the ticket will be alive for another full period. What's the full period? 7 days. That's a week. So if you want to keep the ticket alive, you have to keep paying for the fee. That's every 7 days for that ticket to be kept alive. And then you can keep it alive for as long as you want, as far as you keep renewing the fee. And that's how you manually redeem your code, your ticket. Yeah, so for this, we can just see so there's this part of the code I want to show us. Okay. No, they're not deducted. That's you initializing the ticket. No, they're not deducted. So to first check, the error we were getting yesterday was what it was saying. Let me see if I can scroll up. But from the error of yesterday, you would see that it was returning. Huh? No, it's working. I'm just referring to the error. Let me see. So we are seeing gas required exceeds allowance. So it's going to check your balance. And then, there's the estimate gas fee. You can only use it as for your normal contract. If you want to make a contract call, you can always estimate the gas fee. So it can put all of this in play and try to estimate the gas fee and take a look at your balance. If it sees that okay, your balance is not up to the gas fee, it throws an error. But it won't deduct until it knows that you have a reasonable amount of funds and that ticket has been created. You understand? All right. So yeah, taking a look at yesterday's code. Taking a look at yesterday's code, we can see that after we have registered the custom token, I introduced a new method, which is get L1 to L2 message. Now, this get L1 to L2 message returns status, right, of your current transaction. So it will can return a status of if it is redeemed. It can also return a status of if it's still initialized. So you have all of this. Now in this expert, this is like normal test. I was trying to run some tests on it. So at this particular point, it tries to check the status. So what is happening here is I'm just saying if the status is not redeemed, we're just trying to check if the status is redeemed at this particular point. So this just means this gets one to L1 to L2 messages, right? You call that, and then once you call that, you are going to wait for the L1 side to be confirmed. So that is for the travel ticket to be created and initialized. And then once that is done, you would now listen and wait for L2 to be executed. So waiting for that to be executed, you can now listen to the messages. So if you check this get status, right? Let's check. So you're going to, when you wait for the messages, it's going to return two things for you. One is what? It's going to return the status if it's redeemed, right? And then it will also return the receipt for you at this particular point. And once it's redeemed, you cannot go ahead to perform the rest of your transaction. So do you understand? You can't have the receipt. So the receipt is basically a transaction hash, and transaction hashs are generated after the transaction is successful. So after all the blocks are confirmed and everything is done, that's when transaction hash are created and generated. So yeah, so that's how you listen to your messages. So these messages let you know that okay, these are redeemed. The gateway has been redeemed. The messages have been redeemed. It has been initialized and all. All right. So that's all for today. We're not really doing deep because since yesterday's class covers today's class. Okay. So it has been an honor to teach you guys. So see you soon. See you another time. Remember, you can always hit me up for any issues, any problem. I'll be available for front-end issues and solidity issues. Please let's take note of that. Yeah. So all right. Let's all have a great hackathon. Amusing month ahead of us. Thank you. Okay, instead of let's wait for this to be done. So we can actually see how the token are deposited to L2. So let's just stay on the call and wait for that. So you can throw your questions and ask your questions as we're waiting for this to be done. Okay, guys. We have successfully transferred our L1 token to L2. So let me grab our. So for our L1 token, it was deployed to this address, right? So what I did is I imported the Sepolia. I imported it to our Ethereum Sepolia, and this is it. But then I minted 0.5. Right? So that means I'm supposed to get like 5 of this token, 5 LCT, but I can see 3. Why? Because we have successfully transferred 2 of it. So this is the amount I deposited, 0.2. So I think because of our formatting, that's why it's looking like this. So 5 minus 2 is what? 3. And if I come to Arbitrum Sepolia network, and then I import token to this, I see the 2 of that same token. Can we see how it works now? So we have successfully transferred from Ethereum Sepolia to Arbitrum from layer 1 to layer 2. And then from here, I can now do my transactions, do whatever I want to do on the rest. All right. So that's all. I'll push the updated code to GitHub, and every code that we have used today, both for the front end and the back end, both for the front end and the normal adapt deployment. All right. So take care. See you another time.